Hey everyone, Mr. Boyden here. Today's video is going to be a little bit different than the other videos. Today's lesson, or today's video rather, is just about the quiz we took the other day in class. So if you're not actually currently in my class, obviously you're welcome to watch, but this video is intended specifically for students in my class right now to give feedback on a quiz. So what I'm going to talk about today are some of the common mistakes that I'm seeing on the quiz right now, the correct way to do this, and then hopefully by the end you have some strategies to where you can be really successful moving forward, because we are going to have a test here in a couple days. So let's start with the first one. I want to start with something that I saw that doesn't work, the most common mistake that I saw. In fact, almost everybody who set this up right was able to get the right answer, but one of the mistakes I saw was this. People would start with 5,000 RPMs, although some of you wrote 500, so be careful there. And for some reason, you guys put 1 foot on top of that. Now, I get that 1 foot comes first in the question, but the order of which the wording comes in the question has nothing to do with the setup. There's no connection to that. I can put this information in any order I want as I write a question, and so could you. We have to interpret this. And here's how we would know that this is a big problem. Because how many units do we have? We have feet, we have revolutions, and we have minutes. So in one factor, you have 3 different units. That's not going to work. We're going to be in big trouble when we do that. So what we want to do on this, or what I like to do, I like to start by looking at where am I headed. I'm going to be writing my answer out in miles per hour. So my answer is going to be miles per hour, which is an indication to me that I'm only going to have 2 units. I mean, technically that's one, but miles is one thing, hours is another. So we're going to have 2 units in the answer, which means in my setup, I want to only have 2 units. And I need to have exactly 2 units. So what are my choices? One of the options is 1 foot. I don't want that because that's only 1 unit, or I could use revolutions per minute. Revolutions and minutes, that's 2 units. So bingo, that's what I'm going to do. So I'm going to go with 5,000 revolutions, and the way we set this up, revolutions on top, minutes on bottom. And y'all, we just got to review this, and we did a TOQ. You did great on it, okay? I think maybe we haven't been studying the way we need to, so this is something that's going to be really easy for you to get back. I think you just need a reminder on it. And then we just roll through dimensional analysis on this. So there are 60 minutes in 1 hour. Minutes cancel. We notice in this situation, we've got a saw blade, and it has a diameter of 1 foot. We might remind ourselves that 1 revolution is the same as the circumference, which is the same as pi times diameter. So 1 pi foot, or 1 pi feet, is the same as the circumference is the same as revolutions. So we can cancel out revolutions by putting 1 revolution here, and pi feet up here. And let's cancel out revolutions and revolutions. And we were not asked for feet, we were asked for miles. So we need to remember there are 5,280 feet in a mile. And notice I'm saying these out loud as I'm writing them. 5,280 feet in a mile, 60 minutes in an hour, pi feet in 1 revolution for this context, okay? So we get to here, and I cancel out what I can. Feet be gone, feet be gone. I've got miles on top, bingo. I've got hours on bottom. All right, it's calculator time. So it's as easy as this. 500 times 60, or excuse me, 5,000 times 60 times pi, divide that by 5,280. We were asked to round to the nearest whole. That is 178 miles per hour. Let's go on to the next one. The next one's really easy. I think those of you that struggle with this, you just didn't really recognize necessarily that there's a nice little formula sheet up here. So check this out. How much area does the slice of cake cover? Well, let's go back to the question. It's a circular cake, so I better draw my circle. So here's my best circle, slice of cake. Ooh, that's a sector. Area of a sector. So watch how easy this is. 1/2. What's next? Theta, what's theta? Theta is the angle. They told us the central angle is 1 radian. Okay, that's good. Theta has to be in radians for this formula. So that's times 1, and then times r squared. Did we see the radius? Oh, that was even given. Radius is 4. So 4 squared. 4 squared is 16, so that's 1/2 of 16, which is 8. It's good if we include units. Since it's area, it's going to be a square unit, and since inches was the radius, it's inches squared. Now it's going to go off the screen, but the next one is going to be arc length. And so there it is. And I'm going to just write that down here in just a second. L equals r theta. And y'all, I'm not trying to be sneaky with the way I write these questions. This was intended to be a really easy question, though a lot of us missed it. I even said here, what is the length of the arc? That's arc length. Okay, so that's an easy one. Let's fill in the numbers. What is the length of the arc? Well, that's arc length right there. Do we know the radius and theta? Of course we did. We used it in the last question. So that is radius of 4. Theta is, oops, if I wrote theta. Radius is 4. Theta is 1. 4 times 1 is 4. And since 4 was in inches, this is in inches. Done. That's all it is. Okay, because that's something you can definitely get next time. I'm sure you're going to, those of you who missed it are really going to be hoping for a shot at redemption on that on your test. All right, what about these? Seemed like some of us forgot what these mean, which was a little bit disappointing. Guys, when you see 5 pi over 6, you should immediately think about the unit circle, because we learned about 5 pi over 6 on the unit circle. We remember that tan, yes, it's y over x on the unit circle, or opposite over adjacent, as in SOHCAHTOA. Y over x actually works a little better, so what do you have to do to get this question right? Well, draw a better unit circle than that, hopefully. You notice that over here is 5 pi over 6. I like to draw in the triangle, as we saw in class. To me, the short side is 1/2. That's the y value. So that would be 1/2 for the y. The x is going to the left, so it's negative, and it's the longer side, so it's root 3 over 2. We do need to flip that and multiply it. So I'm going to zoom in so it's a little bit easier for me to write, a little bit easier for you to see. And so, yes, we're going to flip and multiply, so we get 1/2 multiplied by negative 2 over root 3. The 2's cancel. Be careful, the negative is still there. Some of you wiped it out. So I have negative 1 over root 3, and we can't have a root right there in the denominator, so we're going to rationalize that thing. And then we get negative root 3 over 3, and that's what I'm looking for on this. Just so you know, the way I scored these, there's only 1 point. I scored it as you either got it right or you got it wrong. So don't be dejected if you made a mistake here and lost the point, or if you made a little mistake here and lost the point, but everything else was right. But these are simple enough questions. I do now expect that you can get the whole thing. Okay, let's do 2 more so you can make sure you understand the expectation fully. All right, this one I tried to be just a little bit sneaky by putting in a negative angle. You shouldn't be too freaked out by that, though, although I got quite a few of you to bite on it. I was surprised. Because we know that pi over 4 is here, but that's positive pi over 4. And some of you proceeded with the question using this location. It's negative pi over 4. It just means it goes the other direction. So negative pi over 4 is down here. Now what I liked is most of you recognize the coordinates, and you either had root 2 over 2 and root 2 over 2, or here we have the negative version of it for our y value. So root 2 over 2 and negative root 2 over 2 is the coordinates there. Cotangent is the x value divided by the y value, because it's the flipped version of tangent. So the x value divided by the y value, guys, I'm not even going to write out the steps on this one. If you take something divided by the opposite version of itself, well, if it was the same version of itself, anything divided by itself is 1, but that's the opposite version, so that's going to simplify out to negative 1. I don't even need to show the steps. If you just demonstrated to me the coordinates and then wrote down your answer, you're getting full credit for that for sure. What about this one? This one's just cosine, but the sneaky part is the fact that 11 pi over 4 is not on the unit circle, and I made it negative. So let's add a whole circle to that. So I'm going to add 2 pi to that, but I'm going to make it over 4, so we have a common denominator. So I'm going to add 8 pi over 4, and so what do I get? That's the same as cosine of negative 3 pi over 4. So if you want to add another circle to this, you can. There's nothing wrong with that at all, so it becomes positive. I'm pretty comfortable, and I want you to become comfortable with finding the negative version, because all it is, if you know 3 pi over 4 is here, then the flipped version of that, or if you want to think about it as directional, that's 3 pi over 4, so the opposite direction, the same distance, is negative 3 pi over 4. And so all we have to do here is recognize the coordinates. Cosine is the x value. We're going left and down, so it's for sure negative. And anytime it's over 4, the coordinates are root 2 over 2 and root 2 over 2, so that's what it's going to be for the x value, and that's all it is. Now, there were a good chunk of you that did really well on these, and for some reason, you got stuck on 6. So what I want to show you here is that 6 is basically the same question. It just is asked in a different order. So again, we're using trig. We're being asked for theta. The only difference is, notice in these previous examples, you were given theta, so like right here, you're given theta, and you were asked to give the ratio. The difference on this one is, now you've been given the ratio, and you're being asked to work backward to figure out where on the unit circle that was. So here's how we're going to think about this. We're talking about tan, so we know that tan has something to do with y over x. So there's going to be a fraction. And we look at this, and it has a root 3 in it. So either it came from root 3 over 2 over 1/2, because that's one pair of coordinates, or it may have come from 1/2 over root 3 over 2. Those are really the only options. Let's simplify these and see which one is plausible. When I flip up this 1/2, I get a 2 over 1. The 2's cancel, and I get just root 3. That's not it. Okay, so that's out. Let's double check and make sure this one is right. So flip it up. 2 on top, root 3 on bottom. Cross out the 2's. It doesn't look like it matches, but we know we have to rationalize the denominator. And so now I get root 3 over 3. And you go, but wait, it's negative. Gotcha. Guys, you're not worried about the negative yet. Okay, so we get this thing that matches. Now that negative, the way we're going to account for that is by picking the correct quadrant. So let's draw a picture. What we need to get out of this little exercise over here, remembering that tangent is y over x, is that our y value is going to be either 1/2 or negative 1/2, and that our x value is either going to be root 3 over 2 or negative root 3 over 2. The next thing that I identify is, since the y value is smaller, that's the locations on the unit circle that are some number of pi's over 6. And now we slow down and we say, well, wait a minute. Those are the options. When we divide the x and the y values, we need to get a negative answer. Well, in quadrant 1, if you divide x by y, do you get a negative? No, the coordinates are both positive here, so that's not a solution. What about over here? The coordinates go negative, positive. So will that be a solution? Yeah, negative divided by positive, or positive divided by negative, in this case, is negative. So what is this location? That is 5 pi over 6. So that's one solution. What's the next one? This one goes negative, negative. Does that work? No. Negative divided by a negative is positive, not negative. What about over here? We have a positive x value and a negative y. Divide those, and you do get a negative. So that's good. So that's 11 pi over 6. And those are the two answers. Now, for some of you, you got one of these answers, and you got one of the points. When it says to solve, that's going to be exactly like we saw in our homework, where we're asked to find all the locations. Now, some of you said for this location, you called it negative pi over 6. Because my directions were not specific about, for example, having theta between 0 and 2 pi, I'm giving you full credit for that, okay? You're going to get that point. In general, we want the positive version, but for now, that's totally fine. But you do have to have something that represents these two locations in order to get both points. Okay, guys, whenever it says solve, assume we need all answers. And so you have to look for all of them. 3 is where I saw that a lot of us really started to struggle. This looked like the question on the quiz that was the hardest for us as a group anyway. And so let's just kind of roll through it. What I was really happy about is most of you recognize that sine is the flip version of cosecant, so you immediately wrote 1/3. That was awesome, guys. Okay, and that's exactly what I want you to look for. It will not always be the case, but often there will be one of the questions, if there's multiple parts, that's easier than the others. We're asked to draw a picture in the Cartesian plane. That just means like the xy axis. So, or the xy plane, named for Rene Descartes, but that's a story for another day. So what am I going to do here? I'm going to remember that sine is opposite over hypotenuse. And so they're saying also, since it's a y value, I'm thinking about it both ways. I know that I'm not in quadrants 1 or 2 because we have a negative y value. So it's going to be down here. Right here, I'm told that cosine is less than 0. I interpret that as saying x is less than 0, meaning x is negative. So I'm over here in quadrant 3. So that's out. So my triangle is going to be over here. The opposite side is negative 1. The hypotenuse is 3. Let's try to find secant. We remember that secant is 1 over cosine. And cosine is adjacent over hypotenuse. So I know the hypotenuse is 3. So I have 1 over something over 3. I need to know the adjacent side. So let's go find that. So, and a lot of you did this well. You set up the Pythagorean theorem. So 1 squared plus, we'll call it x, and that makes sense. It's left and right. 1 squared plus x squared equals 3 squared. So we get 1 plus x squared equals 9, or x squared equals 8. So we get a root 8. Guys, a lot of you left it as root 8. I gave you credit if you answered with root 8 in here and flipped it and rationalized. And I'll show the right answer you'd get if you did that in a second. However, I want you to remember that root 8 is the same as the square root of 4 times 2, which is the same as 2 root 2. That's a simplified radical, so we really want to focus on doing that. Okay, so that's my side that is x, my adjacent side, except I think it's negative because it's going to the left. So I'm going to pop that in here, negative 2 root 2. Now, you guys understand, the calculation didn't say it had to be negative. Technically, it's plus or minus, right? But in context, we see it's negative because it's going to the left, and we're told that cosine is less than 0, so it can't be positive. Right here, we were dividing by a fraction, so we need to flip that up. So 3 over 2 root 2. And then I need to rationalize the denominator, like this. And so I get 3 root 2 over 2 times 2, which is 4, except I forgot to bring the negative, so let's incorporate that now, and I'm going to bring it to the numerator, and that is our final answer. Now, those of you who left it as this, you got a final answer of negative 3 root 8 over 8. And I'm going to give you full credit for that because you demonstrated really good understanding of concept. I just want you to work towards simplifying your radical like I did right here. And final question. This one looked pretty good. There were some issues on the shift, the vertical shift on this one, so that's what we want to really pay attention to as we go through this one. Okay, so what I saw that was pretty good, most of you immediately went and found the period. Period equals 2 pi over b. b is 3. Can't simplify that, so drop it here. That would be pi over 3, and then 1, 2, 3, 4, and then 4 pi over 3. And then there were some issues with the shifts. So I want to encourage you to go back and actually write it out. The people that I saw that struggled, I don't think any of them wrote out what the high, middle, and low were. So remember, high, middle, low. The high, normally, if that weren't there, the high would have been 2, and the low would have been negative 2, and the mid would have been 0. But we have to recognize that that 2 that I just uncovered is a vertical shift. It shifts up. So the high would have been 2. It's not 2 anymore. It got shifted up. So now it's 4. The mid would have been 0, but it got shifted up 2. So now it's 2. And the low would have been negative 2, but it got shifted up 2. So now it's 0. That's my high, middle, and low, and that's what I saw a lot of people missed. So the low is now here, and then I'm just going to go 2, 4, 6 the way I label this. And now my high is at 4, and my mid is at 2. And so I'm ready to graph this thing. I got my axes all labeled up. I got my dotted lines in. So here I go. We remember that sine starts in the middle and goes up. So middle, high, middle, low, middle, high, middle, low, middle. Sketch that curve. And y'all, that's all it is. Okay, that's this whole question. And my sketch is going to look ugly because I struggled to draw on this thing. But even if you drew kind of an ugly sketch like this, I give you full credit because you'd be demonstrating all the understandings you would need to know. Okay, and so that's what I'm looking for there. So I really want to encourage you to use this technique here where you actually write out if it were not shifted first. So this is like the hypothetical right here, right? If it were not shifted, this is what it would be, but it is shifted, so this is what we're actually going to graph. Okay, I think that'll make it a little bit easier for you. Hope this is helpful to understand your quiz. See you next time.